Alright, so in this video we're going to look at evaluating Laplace transforms. So if we have the Laplace transform of some function f of t, then that's equal to the integral 0 to infinity of e raised to the negative st times this function f of t, and we're integrating with respect to t. Alright, so let's take a look at an example. Alright, so we want to evaluate the Laplace transform of t. Alright, so the Laplace transform of t is equal to the integral from 0 to infinity of t times e to the negative st, and we're going to integrate with respect to t. Alright, so now we need to evaluate this integral here. Well, to integrate this, we're going to have to do what? We're going to have to do integration by parts. Alright, so we're going to let u equal t, so that gives us du equals dt, and then we're going to let dv equal e to the negative st, so that means v, if we integrate that, that's going to be negative 1 over s e to the negative st. Alright, so this is going to equal, u times v, so that's going to be t times this, so that's negative 1 over s times t e to the negative st, and that's integrated from 0 to infinity, minus the integral of du times v. Alright, so I'm going to take this negative 1 over s and pull it outside the integral, so that's going to make that a plus, and we have a 1 over s, and then that's going to be e to the negative st dt, and I'm going from 0 to infinity. Alright, so let's look at this part for just a second and see what happens here. Alright, so let's see what happens as t goes to infinity here. So this is e to the negative 1 over s, e to the negative st. So if I rewrite this as negative 1 over, well, actually we would keep the t up in the numerator, s times e to the positive st. So you can see as t goes to infinity, the numerator goes to infinity and the denominator goes to infinity. So I could use L'Hopital's rule, and so that would be negative 1 over, and then when I take the derivative of this would be what? S squared e to the st. Now that equals that. So, well, not equals, well, if we take the limit st goes to infinity, the limit st goes to infinity, they would equal. Alright, so now as t goes to infinity, this denominator is getting really big and the numerator's at 1, so this whole thing would be going to 0. Alright, so now let's look when we plug 0 in for t. So when we plug 0 in for t, this would be e to the 0, which would be 1, and then this would be 0. So whenever I multiply 1 times negative 1 over s times 0, that gives me 0. So this whole term here is 0. Alright, so let's rewrite this. That's going to be 1 over s, 0 to infinity, e to the negative st dt. Alright, so now let's integrate this. Well, that's going to give me the 1 over s, and then when I integrate this, that's going to be negative 1 over s e to the negative st, and I'm going from 0 to infinity. Alright, so let's do this. Let's multiply these two. So that's going to be negative 1 over s squared times e to the negative st from 0 to infinity. Alright, now we need to evaluate this thing. So let's just write this all out. That's going to be negative 1 over s squared times the limit as t goes to infinity of e to the negative st minus e to the negative s times 0. Okay. Now look at this term. I can rewrite this as 1 over e to the st, and then just like in the last one that I showed, as t goes to infinity, this whole fraction's going to 0. So this term's going to 0. Okay. And this term, well, that's e to the 0, which is 1. So I have negative 1 over s squared times negative 1, which gives me 1 over s squared. And this would be my solution. Alright, so I hope this video helped. I'll probably do a couple of more of these. If you like the videos, you could watch my other ones, and you can subscribe. Alright, thanks.